technology and the overall i-ALERT3 battery life is advertised at 2 to 3 years. We have put a lot of safety factors and a lot of testing, internal and external, to assure our customers that you will get 2 to 3 year battery life even when exposed to higher temperatures.
Yeah, there's a lot of engineering and design that goes into really any battery operated device, right? In terms of making sure that the battery operates for the longest period of time. You're maximizing its life as well as its usage through the operations that you're doing. And I know we've had a lot of experience on that with the i-ALERT2, and as a result, we've been able to build on that experience and that knowledge with the i-ALERT3 to make that battery better.
Absolutely. And again, when it comes to the battery, we have done an extreme amount of testing. We have done our internal temperature chambers. We have put it in different environmental, uh, we have put this into different environmental settings to validate our measurements that we have seen to make sure that the customer gets that 2 to 3 year battery life as we have advertised for i-ALERT3.
Yeah. So I know like some of the other big features or advancements in the i-ALERT3 are related to sensing and the data that it can detect and pick up, right?
One of the things that we wanted to build upon is to be a credible source for your vibration needs. And with the i-ALERT3, we have added, with the i-ALERT3, we have increased the frequency bandwidth to 5 kilohertz. So that gives the customers abilities from a diagnostic standpoint to get early to mid bearing fault detection depending on your running speed. And now with higher resolution spectrums of 0.5 hertz per bin, that gives customers the reassurance that they won't miss an event that happens very close in terms of frequency. And also we have added features like band alarming, the abilities to trend and alarm on frequency bands like your bearing faults or in your velocities frequency that is like your vane pass that now kind of pinpoints exactly where the customer needs are and gives them an added feature to focus on what they focus on what they care about.
Yeah, so those are some really big advancements to really help enhance the diagnostic capabilities of the sensor. Um, you're able to look at your vibration now, not just in velocity, but also in acceleration. Having the band alarming, that's great because you can zoom that in to focus on a specific frequency of interest.
Yeah.
And start to see when that's trending up, rather than waiting until it gets so severe that the entire overall vibration is trending up, which may be at that point too late for certain types of fault conditions, right?
That is correct. And what we want to give our customer is the credibility that they're using a very accurate sensor. From the i-ALERT2 standpoint, we are plus or minus 10% compared to a handheld. With i-ALERT3, we are plus or minus 5% compared to a handheld. Now with the added features, we wanted to make sure that we give you proper, accurate data and then diagnostics, proper, accurate faults. That is possible with the i-ALERT3 sensor.
Yeah, that accuracy and that reliability is certainly very important, especially when you're picking, a sensor or something as a foundation of your condition monitoring program, because you don't want to have something that gives you data that you don't trust,
Exactly.
and you end up wasting even more time chasing false positives or have false negatives where it essentially doesn't catch the issues that you really want.
Absolutely. Some of the other features that we have added to the i-ALERT3 to add to the vibration piece of it and to the accurate vibration piece of it is our flux sensing. What flux is the change in electromagnetic field. So we have definitely want to build on the vibration reliability, but also add another piece of it that can get you electrical health, a trend on electrical health. So from that standpoint on a motor, when you use our sensor, you can get overall changes in terms of your load, and with the spectrum on flux, that gives you added insight of an electrical fault like broken rotor bar, short stator, or eccentric air gap. Those are some of the features that make the i-ALERT3 not just a vibration sensor, but more of a condition monitoring sensor because now we look at vibration, temperature, and change in electromagnetic field.
Yep, that's great. I think one of the other upgrades that we've got is around communication, right?
Yeah.
So we've got a brand new communication module in there. So this now supports Bluetooth version 5. So that improves the speed of the wireless connection as well as helps with the range, right?
Yeah. To that point, talking to our customers, one of the key things that they definitely need working in very unsavory conditions is a robust connection and a consistent connection. That's what we get from Bluetooth 5.0. We get the added data throughput that gets you that data faster, and also with Bluetooth 5.0 low energy, we get a proper, robust connection and a larger range to help in the safety aspect of things as well.
Yeah, and I think that's important for us in the i-ALERT space because the i-ALERT has always been a little bit unique starting from the i-ALERT 2 where we could take that full spectrum FFT and provide that information to the user, right? And so we're continuing to do that with the i-ALERT 3, except now that full spectrum goes all the way up to 5,000 hertz. So that's a lot more data, and that's where the Bluetooth 5.0 really helps is transferring that data across, whether it's to your mobile app or to your gateway, in a relatively much shorter period of time, right?
That is correct. And that's what we want to provide our customers. We want to provide something that is credible and robust. To add to the robustness factors of the sensor, we have added the feature over-the-air update. What this feature gives us is the flexibility to make sure we have a robust product out there, but also to update our software or our feature base to better cater to our customer base.
Yeah, that's right. I mean, it's basically great because it gives the ability to remotely push that software either through the gateways or through the mobile app with essentially little to no effort on the customer side.
Exactly.
And so now when you combine that over-the-air update functionality with the replaceable battery, that i-ALERT 3 sensor module can really be the foundation for a future where you can use that same hardware. Then say in 2 to 3 years when the battery's depleted, you can just replace the battery. As and when we release new features and functionality, those will be remotely and wirelessly pushed to that sensor. So you still have the latest functionality on your sensor with that same hardware, and you don't have to replace the hardware just because there's new functionality now.
That is correct. And that's what we want to provide. We want to give them the full solution of what we want to provide to the customers, but making sure that we give them the best experience using our system. So the least amount of time for them to change the sensor or worry about if they have the latest feature set or not. Those are the things that replaceable battery and over-the-air update gives our customers. So that kind of wraps up with all our features that we are updating with the i-ALERT 3. But what we want to hit on is how we can better help our customers. Like what does our customers get from using our system as a whole? Like what is their return on investment?
Yeah, so there's actually quite a few things where the i-ALERT condition monitoring system can help in terms of a return on investment. One is just being able to have a better understanding of your machines means that you'll be able to increase your throughput of those machines. Just by doing that, you can increase your revenue and have a positive impact on your financials for your plant. The other one is now that you have more information about your machine and a better warning system when issues are about to happen, you can really extend the useful life of your equipment. So rather than maybe performing maintenance or repair operations just purely based on runtime hours, now you can see the actual condition and say, okay, well this machine, we don't really have the wear that we would have expected on any generic model of this machine, so we can keep running it for a certain period of time. And so you can reduce your maintenance and your repair costs that way.
Exactly, and that's what we want to provide our customers, that reassurance that if anything does happen with their particular equipment or anything in the facility, that they're better planned for and they're better prepared for, but reducing that probability of having an unplanned downtime event. And if we have seen from talking to a lot of our customers out there that if any of our condition monitoring services, especially using the i-ALERT solution, if they were able to catch like 1 or 2 different faults, it has paid for their overall condition monitoring services, from talking to our customers, we have definitely seen that from a reliability program, it also continues to find benefits as they use the system year over year.
Yeah, exactly. So it's like, the first save really pays for it. And then after that, anything else you get is like bonus, right? You just keep
Exactly.
getting those annual dividends in terms of savings and unplanned downtime that it can prevent and catch.
Seeing all of that, we're very excited to see how the i-ALERT3 condition monitoring sensor and the overall i-ALERT solution can help you with all your reliability needs and be a partner in your reliability program.
Yeah, exactly. I mean, I think the i-ALERT3 is a big step forward in terms of the sensing portion of the i-ALERT condition monitoring solution. Still working with the best parts of the solution around the AI platform, the i-ALERT gateway, and the automated diagnostics. I know I'm certainly looking forward to going out there, seeing how our customers and our end users can put this to work to really help them in their reliability journeys and improving the efficiency of their plant. Thank you very much for your time. We really appreciate you joining us today.
Thank you.
So I think that gives you a good overview of the different features that are available with the i-ALERT3, along with some of the things that can be done and how it enhances a condition monitoring program. But just to kind of hit on a little bit of the high points here as to some of the advancements on the i-ALERT3 versus the 2. You've got obviously the field replaceable battery, right? That's a pretty big thing. But we've also got a lot of advancements on the sensing piece where you can, you've got a much increased frequency bandwidth on the vibration, where it now goes from 4 to 5,000 hertz. And then we're building into the i-ALERT some more advanced diagnostics features, such as the high resolution spectrum on the FFTs. We've got vibration band alarming on board, and we've got the flux sensor to help with motor health as well. And of course, it still works with the i-ALERT automated diagnostic system on the AI platform. And then we've got some upgrades here around, we're now using Bluetooth 5, so it's got a much faster wireless connection there. And that also comes along with the ability to push over-the-air updates remotely to your sensors. So that way you can get new features and functionality loaded into your existing hardware. Up next, we've got a short video from one of our distribution partners. He's been part of our beta testing program. So he's got a little bit of feedback that he just wanted to share with the group here.
As a sales engineer and a vibration analyst working in the field for 6 years, I've had many customers who utilize redundant equipment and run to failure modes because they don't have the capabilities or bandwidth to predict future faults or even understand that they have current faults that need to be looked at immediately. With the i-ALERT solutions, we've been able to show them equipment that has problems right now and might have problems in the near future. We had one customer, we installed some i-ALERTs on a pump and motor, and immediately were able to tell that the pump had stage 3, almost stage 4 bearing failure going on. And we advised the customer to immediately take it out of service. It was direct coupled to a sleeve bearing motor that the customer knew would cost them over $70,000 to replace, but more important to them, would take over 18 weeks lead time to get in from their supplier. After we advised them to shut it down, they did just that and were able to fix the pump in a very short time and get the unit back up and running. This led them to understand the value of i-ALERT and the value of our services.
Okay, so that was a great video and good testimony from one of our distributors. And now let's move on to the different mounting options for the i-ALERT sensor. So looking at this slide from left to right, the Gould's pumps still have, the vast majority of Gould's pumps still have the I-frame, which is a cutout in the casting, which is already drilled and tapped, so it accepts the i-ALERT right away. The i-ALERT3 is slightly larger, but it still has the same form, fit, and function, and will fit in the casting slot. One thing to note here, that it's not necessary to remove the sensor to replace the battery in the field. Again, the battery just clips on the top. It's the upper blue piece that you see where above the bolt where the sensor bolts onto the I-frame, and this can be done in the field as well as in hazardous areas. Moving over to the right is the epoxy mount. This is great for non-Goulds products or other equipment that doesn't have the I-frame, such as all different blowers, fans, compressors, etc. So you attach the mounting pad, which is a stainless steel piece shown under the orange base of the i-ALERT. That mounting pad is newly designed. It is stainless steel. We've done away with the aluminum. Most every customer can use stainless. The aluminum corroded and there were issues. So you can use that with the i-ALERT2 as well as the new i-ALERT3. So the procedure would be to bolt the sensor to the pad and then epoxy the pad using a special epoxy with metal chips to transmit temperature. You would epoxy that assembly onto the equipment, and then you would install the battery pack, and you're ready to take data. The next, over to the right, one more, is the drill and tap. On equipment where you really want a good permanent fixture mounting the i-ALERT onto it, you would drill down into the equipment, you would tap a hole, 1/4-28, and then you would fasten the i-ALERT base to the equipment. The advantages of drilling and tapping in the first connection to the I-frame, or whether you drill and tap on a machinery, is a slightly better temperature transfer. So you don't have the mounting pad in the way. However, with the proper epoxy and the mounting pad, you still get fairly good temperature transfer, but there may be a slight delay or a slight offset that you need to apply. Also, the prep time of the epoxy is much faster than drilling and tapping, of course. On to the last and final mounting method is the magnetic mount. This gives you, using the magnetic mount, it gives you the ability to rove the sensor to different places on the equipment or from equipment to equipment to decide where you want to allocate the i-ALERTs and put the effort into measurements. The magnetic mount does have a slightly lower frequency response, but it's the preferred way of doing it if you're trying to find a good location to put an i-ALERT. Not shown on here is a fin mount. We will soon be introducing a fin mount to be able to put the i-ALERT on a motor fin, and in doing so, you'll be able to maximize the use of the flux sensor. So the motor flux sensor, again, is capable of detecting motor health issues. It'll detect motor load, motor speed, and by looking at the trending and the FFTs of the magnetic flux, you'll be able to also determine whether that motor is healthy or it has any kind of issues such as eccentric air gap, stator issues, or other motor faults that are common. And we'll be introducing those into our diagnostics shortly as well. All right, on to the next slide, please, Jared. All right, so this is kind of a 30,000-foot view. It's the entire i-ALERT ecosystem from the top down. So starting from the left-hand side here, you apply any of our sensors, either the pressure sensor or the i-ALERT3 sensor, onto the equipment in the proper location. And then that data from those sensors is transmitted wirelessly via Bluetooth 5.0 now into the gateway or still through the mobile app. We have new revisions of the mobile app that are being introduced, actually already available in the stores, where you can use them with the i-ALERT3s as well. Then from the gateway or the cell phone or the tablet, it goes up through a Wi-Fi or a cellular link or Wi-Fi if you're using a gateway, possibly, up to the AI platform. In the AI platform is where all the data is aggregated together. It is displayed, and you're able to look at data from disparate pieces of equipment, multiple sensors. You're able to overlay data. You're able to do the diagnostics and the analytics. Just one point of interest is the data is stored in an AWS, Amazon Web Server database, and we believe in data privacy at ITT, so your data is your data. We do not sell it or use it. And the data is stored encrypted end-to-end, and then the data is, the analytics are performed on the data in the AI platform and sent back down to the phone or tablet or directly to the user from a PC that's connected to the AI platform. So So also the rules engine, just to talk about that a little more in a little more depth, it is available for pumps, of course, fans, blowers, compressors, mixers, and a variety of equipment that you would use the i-ALERT 2 or 3 on. The big thing about the AI platform as well is it allows remote analysis. If you have data, vibration people on staff, and you want them to be able to see the data and do their own analysis, you can do that. As many users as you have at a particular facility that are signed up on the AI platform can view the data simultaneously, virtually from anywhere in the world where you have a web link, and you can get to the AI platform. The diagnostics rules engine it gives you very specific outputs. It'll give you things like misalignment, imbalance, looseness, and then it also gives you a recommended action. Severity, such as it's an emerging threat or you have an all the way to imminent failure and everything in between. And then lastly, it gives you a recommended action. So remove the equipment from service might be the most severe, or schedule a repair might be the least severe on those. And then lastly, the last piece of this is many customers would like to see the i-ALERT pressure, vibration, and temperature data overlaid on their operational data. So we now have the ability to do that. Our software team in Athens has never backed down from a challenge, and they have APIs, which are application interfaces, that allow them to get our data into your system, whatever disparate system that is. And we've done this many times now, and works very well to be able. It's a very powerful tool to be able to see vibration data overlaid with process data in terms of diagnosing a fault or an impending failure. All right. And next, we have a short video coming up with one of our vibration reliability engineers.
Hi, I'm Lloyd Massey. I'm a condition monitoring engineer, Category 3 vibration analyst with the i-ALERT Remote Monitoring Center. We watch the data coming in from i-ALERT sensors for customers who want and need our full support to monitor and analyze and report on their equipment. The i-ALERT's a great device for continuously monitoring your equipment, critical equipment or other equipment, remote equipment that's in hazardous areas. The i-ALERT is particularly a great device for monitoring equipment which has very differing duty cycles or sometimes are intermittent operation. Equipment which operates under different loadings or different speeds, particularly because if you have a handheld device walk around data collection program, many times when you visit the equipment, they're not running, or they're not running in various load conditions which may be detrimental to the equipment, or the equipment may not be operating smoothly in. A lot of equipment perhaps don't run in these conditions at convenient times and maybe are in remote areas. So the walk around program misses a lot of these conditions. The i-ALERT will catch these conditions and makes it all visible to the analyst. The i-ALERT 3 is even better than the i-ALERT 2 in the fact that it gives you data which is higher resolution. It gives you a wider frequency range, which allows you to see more types of defects than before. It gives you an earlier window into certain defects, such as bearing defects. You can see those earlier. It allows you to see further out, say, for example, some gear meshes, some higher speed machinery. And the higher resolution allows you to differentiate and split out some close frequencies, which you didn't have the ability before. So the i-ALERT 2 was great. The i-ALERT 3 is even better. The i-ALERT 3 allows you to see things in your equipment that you will miss in a traditional walk-around data collection program because it's on 24/7 recording the data. And if you have Gateway, you can even see this in near real time. For example, we have one customer who used a traditional walk-around data collection program to collect data from many of their remote sites. They have a lot of remote sites spread across several states, a large area. some of these sites are unmanned. The walk-around program would only see one time per month or one time per quarter, even some of these pumps. And so when the analysts would visit, perhaps the pump wasn't running, or sometimes the pump was pumping a certain product or a certain speed range, loading range where it was comfortable. And when we deployed the i-ALERT sensors on it, it was like looking at their equipment brand new. It's like looking at their equipment, they've never seen it before. And they discovered several conditions on several of their equipment where the pump would run horribly on a different product. And it also allowed them to make sure that they did not go a month or 2 months without collecting data on their equipment. So they could see a lot of things that they weren't even aware of before. For example, we have one customer where they used a traditional walk-around data collection program prior to installing the i-ALERTs. In this case, many times the equipment may not have been running when it was visited for data collection, or in many cases the equipment was operating in load conditions which were not indicative of how it would run under a different product or a different operating condition. The i-ALERT3 would capture all of this data. Once they deployed the i-ALERTs to their equipment, many new conditions were evident that they weren't aware of before, where the equipment was running horribly under certain loading conditions. And this allowed them to, in some cases, change their operating procedures, or allowed them to change how they operated their equipment to accommodate the varying loads better, to extend the life of their pumps. And it gave them a better insight into how to efficiently and effectively plan their upcoming maintenance, and perhaps focus more than they expected to on some equipment that they learned was actually suffering more than they were aware of. So it was a very good insight. It was like a new window onto their equipment that they didn't have before.
So that's the end of our presentation here today. We'll switch over to asking or to answering questions here from the chat. We've got about 10 minutes left, so I'm just going to go through a list of questions, probably from the top here. Let's see. What kind of battery does the i-ALERT3 take? Dave, do you want to answer that?
Yeah, I sure do. So we've used a lithium-ion chemistry. I've been reading some of the questions here as we've been going through. So this question is kind of a common one. I'll answer it. So we've used a lithium-ion chemistry, but it's not the same chemistry we used in the i-ALERT2. It is an improved chemistry of the battery. And I notice also many people are asking why is the battery proprietary, et cetera. And Naveen answered this. I'll go over it one more time. In order to make the battery field replaceable in a hazardous environment, we had to use special pins that break contact before you lift the battery off the sensor. So it's a proprietary design. It allows you to change the battery in the field, and also the type of battery that we use, the chemistry, the size, the shape, a typical battery that you buy at a Home Depot or a Lowe's or a store would not have lent itself to the kind of energy that we needed to power this device and the longevity of the battery. We're very confident. We've done lots and lots of testings. We're very, very confident that this battery is going to have a life that far exceeds i-ALERT2 or any of its predecessors.
Thanks, Dave. Yeah, I think that took care of a couple of questions. The other question around the battery was which part is the battery, so I can take that. In some of the slides or the pictures, you probably saw there's an orange base, that's the actual sensor, and then the blue top, that piece incorporates the battery in there. So the blue piece is the battery module. So what is the frequency response for the i-ALERT3 sensor, both on the low side and the high side? Dave, do you want to take that one?
Yeah, certainly do. Okay, so we did some things on the i-ALERT on the i-ALERT3. We increased the resolution down to 0.5 hertz per bin. Okay, and we go all the way down. We measure down to 1 hertz and all the way up to 5 kilohertz. For display purposes on the FFT, we will show you all the way down to 1 hertz. I know there was somebody had a question in there. They said we needed to go below 240 cycles per minute. So we do go down to 1 hertz. We do go below 240 cycles per minute on the FFT. However, in computing the overall, the RMS, we use 4 because we don't want to introduce, there's additional noise. The lower you go in frequency, you introduce more noise into the spectrum. So we wanted to eliminate that noise from the overall RMS to give you an accurate RMS value. So we're all the way from 1 hertz to 5 kilohertz, which is a greatly extended frequency range. And bear in mind that with the magnetic mount, magnetic mounted is probably not good beyond 1500 hertz. Just to keep that in mind. I mean, even though we use a rare earth magnet, which has a tremendous amount of pull, it's probably not recommended to use a magnet mount beyond 1500. Okay.
All right. Can the i-ALERT3 confirm if a motor is electrically energized? Dave, I'll let you take that one.
Yep. Yeah, sure. So 2 things. In our testing of the magnetic flux sensor, obviously, if the i-ALERT is mounted on the motor, either epoxied on the motor or using our upcoming fin mount, it definitely absolutely can tell if the motor is energized. In fact, it can tell you more than that. It can tell you the load on the motor. So you'll be able to see the load and the exact speed from the magnetic flux, the synchronous speed of the magnetic field. However, in our testing, we've noticed that even if you put the i-ALERT on an adjacent pump, the magnetic flux sensor automatically adjusts its gain, its sensitivity, if you will, to be able to detect the flux. So in many cases, even if the i-ALERT is on an adjacent pump, you can still measure that motor flux. The danger there is you're trying to measure a signal that's a little bit far away. So if there's another motor in the area, be careful. You may be picking up that motor. It'll detect whichever motor is closest to the i-ALERT. But if you have an isolated pump and motor out in the middle of a facility and it's far away from anything else, yeah, the flux that you're reading is from that closest motor. So very versatile.
Okay. The next question is, will i-ALERT2 data transfer to the i-ALERT3 software, or do you have to start all over? I can take that one.
Absolutely seamless. Oh, go ahead. Knock that.
Oh, thanks. Yeah, so that's like you were starting to say there, Dave. That's seamless. So when you replace an i-ALERT2 sensor on a piece of equipment with an i-ALERT3, when you look at that data in the AI platform, you'll be able to see all the i-ALERT3 data as well as all your historical i-ALERT2 data on that machine. You'll be able to see just your overall data as well as your FFTs, whether they were gathered by an i-ALERT2 or a 3, or maybe even a combination of sensors on that asset train. Let's see. I think we covered the frequency range. There's a couple more battery questions that I think you covered. Are 2 sensors required for a pump and motor application? Dave, do you want to answer that?
Yeah, sure do. I think Naveen may have already touched on this, but his answer is spot on as usual. The answer is if you want the maximum utility from the diagnostics, you want to have the best diagnostics possible from a piece of equipment, then you do want 2 sensors as a minimum on the equipment. I mean, typically we put a sensor on the inboard of whatever is being driven, I call it the business end of whatever is being driven, and then the second place for a sensor would be on the outboard of the driver, whether it be an electric motor, turbine, DC motor, variable speed motor, whatever. So you want a minimum of 2 sensors. Optimally, 4 sensors if it's a critical piece of equipment. So one over each bearing essentially, but you can get away with a minimum of 2. I mean, absolute minimum of 1 if you're really, the piece of equipment is redundant, you have spares, it's not critical to your operations. All right.
Okay. There's a lot of other battery questions that I think you answered there, Dave. The next one is around the gateway. So what's the range from the sensors to the gateway? And I think, are the gateways rated for use in hazardous areas, indoor, outdoor? I can take that one. So the range from the sensor to the gateway really depends on the field environment. It can go from about 150 to 300 feet. The gateways are rated for Class 1 Div 2 hazardous areas, and they are rated IP68 for outdoor use. What else do we have here? Oh, is the sensor rated or tested for use in very high humidity environments? Dave, do you want to take that?
Yep, sure do. So the sensor, we've tested it for IP68 and washdown, and we also have done immersion tests on it too. So I mean, actually, the sensor is completely potted in epoxy underneath the battery case, and there's no issues with water ingress. I mean, obviously they won't work underwater because the Bluetooth signal won't transmit, but they are completely encapsulated. So the answer is yes.
Okay, we've got 3 minutes here. I think there's maybe 2 more questions. What is the maximum temperature where the i-ALERT3 sensor can be applied? Dave, do you want to talk about that?
Yeah, sure do. Okay, so the maximum temperature, the survivability temperature of the i-ALERT3 is different than the usability temperature. So I like to talk about it in 2 different terms. So if you were to take an i-ALERT3, put it on a piece of equipment, and the surface temperature of that equipment gets up to perhaps 220 degrees Fahrenheit, or, well over 100 degrees C, above boiling point of water, it would survive. When the temperature comes back down, you will still have full functionality. Unlike in the i-ALERT2, where you could damage it if you went high enough. However, we don't recommend using the i-ALERT3 in any environment where the surface temperature is sustained at over 175 degrees Fahrenheit, because what will happen is that will affect your battery life. It will pull down the ability of the battery to give you a full life of the battery. However, it will work fine at those temperature ranges. So just something to keep in mind. And that's a highly dependent, it depends on the environment, because there can be convective cooling over the top of the sensor. I mean, if you had a fan blowing on the sensor, depends on the mounting. If you have it directly mounted with a screw, there's going to be a much higher heat flux, heat transference from the equipment to the sensor versus if you had it epoxy mounted with a pad underneath it. So the question's highly variable, but as a guideline, I would not go above a sustained temperature of 175 on the equipment, and a damage to the i-ALERT temperature of about 220 degrees Fahrenheit. All right.
Okay. And the last question we've got is there a maximum number of sensors per gateway? I can answer that one. So there's no change in terms of the maximum number of sensors that a single gateway can handle. We've tested it to about 250 sensors going through a single gateway. So it's a pretty high limit there, and frankly, even that's not quite the limit. That's the end point of our test. So I think in terms of practical usage out in the field, we haven't seen any applications where, you're trying to get anywhere close to that number of sensors through a single gateway. I think that's it for the questions, and we're actually right on the top of the hour here, so that's our time. Thank you very much for joining us today. As you've heard, we're really excited about having the i-ALERT3 sensor available out in the field and enhancing the i-ALERT monitoring solution. So if you've got any further questions, please feel free to reach out to Dave, myself, or Naveen. And you can always reach out to your local Gould Pump sales representative to talk about the i-ALERT and how we can help you with your condition monitoring system. Thank you very much, everyone.
Thanks, everyone.